Graph linear inequalities on Cartesian planes. We also call them coordinate planes. Now, the question here is represent linear inequality on the Cartesian plane, and we have two inequalities right there. One is 2x minus 3y greater than 6. The other one is 2x minus 5 less than equal to 7. Now, you've done so many inequalities by now, you should be in a position to do it on your own. So you can pause the video, write down your solution, and then look into my suggestion, right? Now, let me draw a Cartesian plane for each. There we go, right? I'm not using graph papers here, mainly because I don't want to restrict myself. Here, we can always draw with the pen on the paper, few lines, and get the job running, okay? Now, we have the line 2x minus 3y equals to 0. Oh, sorry. We have a line 2x minus 3y equals to 6. But what we want is 2x minus 3y greater than 6, not equal to 6. That is what we want, right? So it really means that we are looking for something which is not, so we don't want 2x minus 3y equal to 6. That we don't want, right? So, but it helps to start with somewhere, right? 2x minus 3y equals to 6 is a good starting point, but we'll cross it out from in between, leave it as a dotted line, as that is not a part of solution, but that is, I should say, as that is not our solution, but that is an important part of our solution. And that's the reason I'll try to sketch a line 2x minus 3y equals to 6 and then kind of get rid of it by showing it as a dotted line and then plot our solution on the Cartesian plane. So that is the strategy here. Now, how to draw that line? To draw this line, what we can do is you can find X and Y-intercepts, right? So we have 2x minus 3y, let me say not equal to 6 or equal to 6. Let's find X and Y-intercepts. So let me start from here. Let me write 2x minus 3y equals to 6 to start with, and find X intercepts. X intercepts means y equals to 0. So if I put y equals to 0 here, we get 2x equals to 6. 6 divided by 2 gives me x value of 3, right? So we get here x equals to 3. So that is my X intercept, right? So this is X intercept. So x equals to 3, let's say 1, 2, 3. That is the point which we are talking about, x equals to 3. Now let's find the y-intercept. Now to find y-intercept, I will plug in x equals to 0. So when I plug in x equals to 0, this becomes 0. And I'm left with minus 3y equals to 6. And that means y equals to 6 divided by minus 3, right? Let me write this time 6 minus divided by 6 minus 3 and minus 2. That means 1, 2. Right? So that point we're looking for. So this is the line 2x minus 3y equals to 6. It's a very important line for us, but not for the solution, right? It is definitely a part of solution, correct? So that is the line. Since it is only greater than 6, not equal to 6, we have drawn this line as a dotted line, right? So this symbol where inequality is missing equal to is represented by a dotted line, right? Now the second part of this is which side to shade. It is either the one which has the origin or the one which is away from the origin. So that is how you can see it. Now to shade it, we need to just plug in 0 here and check. If I write 0 here, what do I get? 0 minus 0, which is 0. And is 0 greater than 6? No, that's not. So we got to shade it on the other side, right? So we just shade it on this side and we get our solution, right? That is how we do inequalities, and that is the best way of doing it. So you don't have much to do. You have to draw a line, and if the symbol does not include equality, make it dotted. And then check with the origin whether that side is included or the other side is included. So the answer is like yes and no. And you get your answer, just shade it and move on. The next one before us is 2x minus 5 less than equal to 7. is kind of simple but tricky. If you look at it, it is basically 2x. Let's add 5 both sides. Then it becomes less than equals to 7 plus 5. Do you see that? So rather, it is 2x less than equals to 12. So that is what it is. So we can further simplify this, and let me leave some more space here for my graph to fit in, and we can divide by 2, and we get x is less than equals to 12 divided by 6, or x is less than equals to 2. That is what we get, right? So we are looking for an inequality which is x less than equal to 2. So let's show this line on a graph, and since it is less than equal to, it will be represented by a solid line, right? And let us say this is our line which represents x less than equals to 2, right? Now, so this is the line which is x less than equals to 2. That means it has a y-intercept, the x-intercept as 2. X less than equals to 2 will be a line parallel to y-axis, will not have any y-intercept, right? Undefined slope, a vertical line through 2. And at every point on this line, you will notice the value of x is just 2. And what does it say? Less than equal to. For equal to, we have made the line solid, and for less than, we know it is, the arrow is showing us, it is on the left side, right? So let's just shade it towards the left side, right? So that is the part of solution, right? So these arrows indicate that we are interested to the portion, including the line left of the line. So that represents x less than equals to 2. And that is how we do linear inequalities on Cartesian planes. Now, if you want, you can check this one also. That is, let's check with x equals to 0. Is it on the shaded portion? Yes, it is. 0 is less than equals to 2 is true for us. So that is how we can check and be doubly sure that the job we've done is perfect. So have a good look at it, and then move on with more examples on linear inequalities on coordinate planes or Cartesian planes, or both is one and the same thing. Thank you, and all the best.